We live in a rapidly changing world, and it's very interesting to be talking to you as friends in industry, as well as academics who are friends in research. For all of us, change has been extreme, and my talk builds very well on the first talk that Andy did, which showed us that if we really want a low-energy future, we have to work with the ambient forces around us and to use storage to optimize their value in dynamic systems. We then saw Jeremy, who was talking about the solar revolution, which has been a phenomenon in the last 20 years of my life, for instance, to see it going from the year in 1995 when I built the first photovoltaic roof in Britain, when the UK PV Society said that domestic photovoltaics will never take off, to seeing a exponential growth in the solar industry too. Designers, if we want real world, in the academic world now, we have to have what the research assessment exercise calls impact. And that means that actually our work has an impact on the world around us, that we're providing value for money for society in what we do. So I'm going to talk about this and try to give a focus of how our work, our research in the university, actually affects people around us in society. You know, for designers out there, and I know there are a number of architects out there here, we live in a world of rapidly changing costs where labor, fees, manufacture, transport of goods are rising rapidly. We've got unstable building markets. In June 2010, do you know how many houses were completed in Scotland? Not one. Not one single house in that month got a completion certificate. How do we survive and support our industries without going bankrupt? And unfortunately, last Friday, I spoke to a number of people whose businesses were teetering on the edge in the building industry in such markets. And as the competition gets fiercer, we find it increasingly difficult to develop good business or robust, sustainable business models. How can we in universities work with you to make a difference in that? Not least, we have the increasing complexity of buildings, which makes things extremely difficult. Now, I'm talking about how we can make a difference for the ordinary citizen, for instance, in their own home. And for all of us in our own homes, we've all become victims, really, of rapidly rising energy prices, again, lowering wages, and a lot more of us are unemployed or finding it difficult to get jobs. So, added to that, we then get the extreme weather events. Do you remember the sudden end of November 2010, when you suddenly woke up and it was the beginning of a 2-month freeze? What happens if you already had difficulty paying your energy bills before that? These extreme weather events are going to make it more and more difficult for ordinary citizens. And fuel poverty is a growing problem, not least in Scotland. Do you know that about 30% of homes in Scotland are in fuel poverty? And in rural areas, that shifts up over 40% of people in rural areas in Scotland have difficulty paying their bills. So we live in a warming world where these more and more extreme events, and here you see the black star there, which represents the outlier for, do you remember 2003, the heat wave? Some of you might even have been in France, where 52,000 people died in their own homes across Europe. 15,000 at least in France, where we saw all those pictures of the elderly piled up in hospitals and so on. By 2030, that year will be every second year that hot, and by 2050 it's predicted that will be a cool year. So we need to build stronger buildings. We need to build buildings that can keep people safe and comfortable in their own homes, and lower their energy prices at the same time. Is it possible? Well, the dream in 1995, when I built the Oxford Eco House, which was that first PV roof in the UK, was that we could do it. And to be honest, I think my last gas bill for the last quarter in the Oxford Eco House, which I still own, was £20 for the quarter. It's not rocket science. And anybody who's interested in it, I think there's a flyer for the 4th edition of that book. We can all do it. It's not difficult. It does cost money. But houses that keep you safe in extreme weather, keep you cool in heat waves, keep you warm in extreme colds, it's possible. That was 1995. It was a technical challenge. Then it was easy to do with 1995 building regulations. It's not about building regulations. But then we went on to look at this issue of climate change and how do we adapt. There's the two angles of climate change. There's mitigation, reducing carbon emissions from the built environment, and then there's adaptation. How do you keep people safe? Well, we have been working diligently with a wide range of people and a wide range of milieus to try and make a difference, to mitigate and to adapt. And we've been doing this in partnership with companies and different groups across Scotland. So for instance, AES Solar, who built my first solar hot water roof in Oxford in 1995, we've worked with on and off ever since. They are a solar hot water company. They're the oldest solar hot water company in Britain. They came out of Findhorn, which is, you know, the sort of the dream of the ecological communities up there. And they have been, you can see some of their work. This is the solar hot water systems they put on the Scottish Parliament. And working with them has given us an opportunity to work in a number of different projects. Because if our challenge is to improve the life of the ordinary citizen in Scotland, then we have the majority of the buildings already existing. Over 25% are, for instance, these heavyweight tenement blocks. So here is a project done by Lister Housing, by Changeworks, and by AES Solar, where they took historic ancient tenements in the centre of Edinburgh and put solar hot water systems on these tenement blocks. And you can see them being lifted on there. In so doing, they halved the actual energy usage of the different people living in those tenement flats. And if you want to see, there's a really excellent YouTube video we made of the Scottish solar industry, how and where you make panels in Scotland, how they're used, and also shows you how they refurbish these particular tenement blocks. So we were working with them on that. But just as Andy said that the key is storage, we've identified here that if you want to try and run the world as much as possible on clean, free solar energy or renewable energy, then you need storage. So this is fantastic work done by Fan Wang and two of our master's students with Changeworks too, funded by Kickstart and working with AES Solar. So what we do have is the opportunity, if any companies want to do a bit of work or consultancy or test products, they can come to us and we can identify small pots of money to put in place research such as this. So I've been discussing already with some people the idea of little pieces of work we could do together, and there's funding out there for this sort of stuff. So what Fan did was he looked at the heating requirements in these tenement blocks, and he looked at the domestic hot water requirements, and he looked at the monthly solar availability, and you can see in that green line there, and the annual heating with domestic hot water. And there's a sort of mismatch. So there's some spare energy. There's some spare energy here at times of the year. There are some times of the year where you can sort of run your solar hot water on on the available solar incidence on a roof like those tenements. And I must say that this might actually be in April or September. If you have a really hot spell, then you're going to be able to generate most of your hot water with solar energy. But what do you do with that leftover residual hot water? So if you take the traditional solar hot water system with the panels here going into a cylinder, maybe backup gas boiler, and then heating wall panels, what Fan did was to take a tenement block and some of those large heavy mass internal walls and develop a wall heating system that would only take the excess heat from the solar hot water system and would place it in a series of pipes built into the wall itself. And then they could use the heat embedded in that, which is just gently raise the base temperature of those tenement buildings. And you combine that with, for instance, air draft lobbies down in the ground floor rooms. And what he was able to do was work with Aquatherm and AES Solar, who provided the panels. Aquatherm provided the wall integration systems. And he built mock-ups and then placed it in one of our climate chambers and ran it for a long period, so we could actually see with a solar hot water storage tank for the hot water, and then in certain conditions, taking off excess heat, placing it in the wall. And he found some really interesting results. And he was able to validate it with, computational fluid dynamics and so on. And he's still working on this. So he's got stored energy over time with input heat, plaster losses, concrete losses, and stored energy which could be used to heat these tenement flats for free over time and interseasonally as well. This is expensive at the moment. He's got payback times of 16 years, but it's really at the experimental stage. So what he's saying is we have a real problem, we have an opportunity with solar hot water, we have a certain type of building stock, so we can develop Scottish solutions which really build in storage and whole building warming there. So that's an example of how we were able to work, not only with individual industries to promote potential products for the future, but also with real problems in the real cityscapes of Scotland. And you can see how sensitive an area this is and the absolute negligible visual impact of the proposals there. But in order to be able to get replicable science, you have to be able to apply it to other buildings. So that might have been one tenement where it worked in a particular orientation and location or city. So we're working now with IES, and we're working with the Energy Technology Partnership in Scotland, and we've got 2 joint or shared PhDs, one of whom, Will Finlayson, is looking at what modelling protocols can you use to integrate optimally the renewable energy contribution into building performance models, and the other one is looking at what protocols are really best used for generic industry standard building models for thermal storage in systems, because while Andy was looking at storing underneath bitumen pavements and roads, we have a huge amount of thermal mass already embedded in the buildings of Scotland. How do we use them at the moment? We don't, because we don't really have the models that deal with it. So we're working with IES to extend mass and renewable energy integration into the models. Existing models, if you take a passive house model, doesn't take account at all of the thermal storage contribution. The existing SAP model is unrealistic. So we're trying to develop new and revised building level models to make sure that ordinary designers can really integrate intelligently thermal mass into buildings to enhance thermal comfort and in different climates, and how do we cost those interventions. Another way that we're working with industry is, for instance, one of our students, Catriona Strachan, got a Shell Step scholarship to work with AES Solar to help them develop more cost-efficient panels for their products. So she looked at all of the different elements in their products and was able to come up with recommendations, analysing existing collector construction, roof fixings, and doing life cycle costing for that particular product, and was able to come up with revised and simplified and refined whole panel designs too. So that's another thing that we're happy to look at with different students if people want people to investigate products. Because, I mean, ultimately the bottom line, it does come down to this human cost of technologies, lowering the unit cost of, for instance, solar technology, widening the solar reach. I don't know if anybody saw my letter in The Guardian yesterday, where I pointed out that the 240 billion that the government is talking about giving to the nuclear industry means a figure of £10,000. That's over the next 40 years. Means a figure of £10,000 for each house in Britain, with which they could put on, 4 kilowatt peak, solar hot water system, draft stripping, insulation, to take every home in Britain out of fuel poverty. It's an investment choice, isn't it? Well, in our concern, and one that I had very early on, having been a politician for 7 years, is the issue of fuel poverty. Because we've seen in the Arab Spring the social cost of people who are angry because they can no longer pay their bills. They're not getting a fair deal. How do we create a resilient and robust future society? You see those entrenched areas of the tenements, that's where the huge fuel poverty is, in Edinburgh. And long ago, when I was a politician building low-carbon communities, you can see here, this was a low-carbon Wolvercut in Oxford, where they said this was proof positive of global warming because underwear is getting smaller. Working with people who's in my were in my ward, like Mark Linus and the vicar and the local green, you know. We created an agreement, a compact, that every house in the ward would be low carbon. And that low carbon communities dream is something that feeds into the Solar City movement. And you can see here, the first Solar City Congress was, the dream was city-wide solar systems. And we had early on, we're coming up to our 6th international conference now in Buenos Aires, but these are the types of solar cities around the world. We've got 66 solar cities now in India alone. And you see Dr. Pachauri here in Oxford in a conference I run, where I think Andy and Jeremy were also there, with mayors from cities around the world building this dream, and actually developing climate change action plans, developing carbon accounting tools. Please hold that thought. There are solar cities around the world. Ota City in Japan, Freiburg, Germany, Dezhou, China, Australia, India. This is Abu Dhabi now, and also Jeremy's own work in London. And we have in Scotland our own solar city Dundee, and who are very active. They've got a team of 4 people now, actively working with each house and each community to see about their needs for insulation and solar technologies too. So trying to find outlets, because we can help as academics. And when we were looking at the brilliant range of stuff we do, it's very important I could see key markets for each of those product types. So we were able to use our academic students, because we have one great resource in academia, which is brilliant students. And this is George Andriadis, who did a study. This is Dundee, a really sunnier city than Torquay. Do you know what? It's got a lot of re-reflectance off the Tay. It's really high solar incidence. He was looking at fuel poverty in the different wards, and he was looking at the solar availability. He did a study, and if anybody's interested, I can give it to you. For 87 million, we could put PVs and solar hot water on 2,000 houses. We could put new boilers in many of them, and we could put insulation in a lot of them. That would take 2,000 of the worst affected, fuel-poor in Dundee out of fuel poverty forever. And, I mean, we've got academic papers on this. 87 million, you say, golly, that's a lot of money. That's 1/4 of the cost of the proposed new Aberdeen Ring Road, which is thought unnecessary by locals. So if people are going to put infrastructural investment in, what is that human cost? Why not put investment into raising the lifestyle quality of every citizen in a city rather than encouraging more vehicular movement around it? 87 million is what the new V&A is going to cost in the area around it. And it's a matter of priorities. By the way, this is all on floodplain too, coastal floodplains too. So where do you make smart investments? What we've got here is, this is Ota City. What they've done here was they developed an entire city with microgrid, optimized microgrid, and they developed a whole new set of products associated with that microgrid. And they were able, there's about 5 gigawatts, 1 million roofs in Japan, and 100 gigawatts they're planning for 2030. Self-sufficient buildings, self-sufficient people, self-sufficient societies, systems in which you can load shift, you can load shave, and you can store. Well, Findhorn, with the ecological communities, pioneered solar energy in Britain at Centre for Alternative Technology. Look what they're pioneering now. Eddie Owens and the team, he's just won 4.5 million euros to take Findhorn microgrid, it's a sort of ecological community with a microgrid, 4 wind turbines, solar, living machine, lots of different stuff. But they have never optimized it. So he is doing that research like they did in Nido, in Ota City, and they will be developing a whole new optimized smart grid, which is neighborhood smart grid. So that, again, pioneers here, and I think there's 3 different ecological communities. It's really hippie communities around Europe. I think they've just come back now from Spain, was it, or France, or somewhere, from one of them. But again, they will be leading a technological revolution. But in order to ensure that the development we have in the future is correct, we have to be able to account properly, which is why I'm working with Sam here and Keith Baker from GCU, Rachel Dunk from the Carbon Crichton Centre, Edinburgh University, ECCI, with ICARB, the Initiative for Carbon Accounting. A group of academics, policymakers, professionals wanting transparency, consistency, accuracy in carbon accounting. So if we're told that nuclear has so many carbon emissions per kilogram of per kilowatt generated, or wind or solar, we need to know that they are correct figures. So Scotland is leading the world in this. Watch this space. We've got our conference on the 13th of March, and on the 14th of March we're taking a charabang or a bus out to the Whiteleys wind farm with experts from, for instance, the USA and so on, to look at how it's done in society. So we'd like to invite you all along to the ICARB conference, and you'll see the stand outside there too, because we have to know that the decisions we make going forward are the correct ones. So we're also working to do that. So I'd say that Heriot-Watt enabling a solar future for all, with brilliant leading-edge research, with connected research challenges and projects, and joined up Scotland, driving genuine low-carbon innovation. And as an example of this, Dorothy Hardy is doing glass art that's actually photovoltaic, so you've got beautiful art pieces like this which generate electricity. So you can't get much more leading edge than that. So thank you very much. I hope that demonstrates we're working for impact too.